Hi, everyone, and welcome to our Lattice Thought Leadership panel. Today's topic is going to be how applications determine AI development. My name is Matt Dobrodziej. I'm the Vice President of Segment Marketing at Lattice Semiconductor, and very excited today to introduce Bob O'Donnell from TECHnalysis Research. He is the Chief Analyst and President over there, and also Hussein Osman, who is our Director of Segment Marketing focused on AI applications at Lattice Semiconductor. So we do these LinkedIn Live sessions on a regular basis, and we really want to focus on really innovative, new market-leading topics that have a lot of buzz, but also really require our community of customers, partners, and makers to really leverage some of the technologies that we're developing to help create new innovative AI technologies for the edge. So today I'm really excited and privileged to talk to Bob and Hussein and talk about what's happening in the AI market and how we can help our community in bringing some of these market-leading innovations to the edge. Bob, Hussein, do you want to just introduce yourselves and talk a little bit about what you do?
Sure. Thanks, Matt. So Bob O'Donnell, President of TECHnalysis Research. I've been a tech industry analyst for a little over 20 years, working with lots of big tech companies across devices, semiconductors, software, services, you name it. I write regularly for USA Today, for Forbes, for LinkedIn, for TechSpot, for Seeking Alpha, do a lot of TV and press, and really excited to chat about AI and how it's moving to the edge and what the implications of that are.
Awesome. So great to have you. Hussein?
Yes, thank you, Matt. Hussein Osman. I'm responsible for the SenseAI stack at Lattice. I've been in the semiconductor industry for about 20 years. I spent quite a bit of that time bringing new technologies to market as an engineer. My interest in AI lies in creating innovative applications that work for everybody.
Awesome. Hey, thanks, Hussein, for joining. So, hey, I'm really excited because what we hope to achieve here with our subscribers is really to inform you on really what's happening in the marketplace around artificial intelligence and machine learning, but at the same time help you in solving some of the challenges around creating AI models and making it easier to work with some of the most leading technology, which we're proud to be part of, in implementing these designs. So just to kind of start the conversation, maybe Bob, could you just tell us a little bit about some of the trends that you're seeing in the marketplace and some of the problems that engineers and AI developers are trying to solve?
Sure, Matt. So, I mean, the exciting thing about AI and ML is, this was the domain of science fiction and of advanced research, university studies, seems like not that long ago. And now what we've seen over the last 10, 5, 4, 3, 2 years is taking that technology and bringing it into mainstream. We're seeing it, we see it in our smartphones, we see it in our PCs, we see it on factory floors, we see it in healthcare equipment, we see it in smart home devices, all kinds of places. And so it's really coming to life. And the challenge these days is, okay, how do I take these cool ideas? How do I figure out how to do this pattern matching and training data and turning it into something that actually makes a product smarter and more useful? And that's the excitement that we're seeing. And, the other thing that we've seen really is, and you mentioned it briefly in your intro, is AI is moving to the edge. In the past, when we first saw some of these implementations, and again, not even that long ago, everything happened in the cloud. If you think about, for example, the first Amazon Echoes with Alexa, basically that was a microphone and an internet connection, and all the audio was digitized, then sent to the cloud, and then everything happened in the cloud. And now what we're doing is we're seeing more and more of that AI occurring on the device, the implications of which are huge. So to me, that's the big picture is this idea of taking this really cool science fiction like technology and then making it real, and then making it real in small, even battery powered devices. And that's a really exciting development that I think we're going to continue to see evolve over the next several years.
Yeah, we're certainly seeing that from our partners and our customers, and that's really well said, that the way that companies are solving and the way that customers are solving AI problems is different than they were before. And the need for localized computing has certainly different constraints and different trade-offs than doing an AI application in the cloud. Could you maybe yourself or Hussein just kind of touch on, hey, what are the big differences when you're looking at, trying to solve an AI problem in the cloud versus the edge, training versus inference? Could you maybe just go into that a little bit so that our audience can get a basic understanding of what you mean?
Sure. I'll briefly touch on it, and I'm sure Hussein can give more details. But, the basic concept with AI is that a lot of it involves sort of sophisticated pattern matching, seeing a whole bunch of data, seeing what happens in reaction to that data, and then programming something to have that reaction when it sees that data. So training is the process of either, for example, of image recognition is looking at all kinds of different images which are defined and given labels. In the early days of this, it was called labeled data. And you would, it'd say, this is a dog versus this is a cat or whatever. And then we learn, oh, I see dogs have all these characteristics. Then you create a model that says when a camera image came in, it could determine, oh, actually that's a dog or a cat with a certain degree of accuracy. Anyway, you take that principle and you apply it many times over. In the past, the big problem was it required enormous computing power, both literally as in compute capabilities and huge amounts of power to drive these things in huge data centers. Now, of course, what we're seeing is we may have training done in the cloud or in the data center, but the actual inference, the process of determining how to react to a given input is happening locally, and it's happening with much less power. So I'll pass it to Hussein to provide more details.
Yeah, I'll go a little bit more on the drivers for that rise of edge computing. I think those are important. And, user security, privacy, latency requirements are really strong drivers for why edge AI computing is in the rise. And we're seeing an explosion of that over the past 2 years. In addition to these drivers, there are also innovations that happened in the past few years that are strong drivers. For example, there's hardware choices that are efficient and able to run AI models in similar capability to what happens in the cloud. So that's an important innovation. The AI models themselves have evolved over the past 5-10 years to become a lot more efficient. They're smaller in size. They work well. So system designers have choices in running AI workload on device versus the edge, and edge is definitely in the rise at this point.
No, it's a great example. It's interesting. I think we've all had that moment going through the airport where all of a sudden some type of computer vision innovation is kind of introduced to us without us even knowing it. We go from even needing boarding passes to now it's all done through facial recognition, going to a database somewhere and verifying that it's you, and it's as good as a boarding pass to get you on an airplane, right? Or some of the things that we go through when we go through services such as global entry, where all that information replaces your physical passport. So I think people are getting more and more comfortable and seeing this as part of their daily lives, which is what makes it so exciting. What I think our viewers would be really interested in is like, hey, how do I get started? Because first, what are the kinds of problems and use cases that we should expect AI to start doing for us, like those airport examples, like those customs examples? And then if you're a developer that wants to get into this space and utilize the latest and greatest tech, which we can talk about why we are absolutely awesome at doing a lot of those things, tell our listeners how to get started. That would be really helpful to just kind of map out some of the problems and how to think about the problem and creating a solution.
Okay, so let me take you through the journey of going from an idea or a concept of an AI use case to get it to production. And I think of this as 3 stages: ideation stage, where you decide on the application and the application requirements. Then there is a design stage where you go through building the model or taking a pre-designed model and then training it. And then the last stage which is testing to make sure what was designed work as expected. So to give more details, let me pick an end product as an example. Let's take a robot, for example. Building an AI workload for a robot would be, first, you need to understand what the application requirements are. Are you using this workload to navigate the robot, or listening to a key phrase when the robot is asked to do something? Based on that, decide on what are the application performance needs, how much processing power is required. Look at what power is available, what size battery, and how long does that battery need to run on. So understand well the application requirements. Also take a look at the system being built, what sensors are available to extract data from to make the application smart. So these are the important pieces looking at that. After deciding on the sensor, the application goals, then we move into deciding which model to use. There's a variety of the models that are available there and out there in open source community, and deciding the model decides on what kind of application you're looking for: detection versus tracking versus other use cases. You have different models. Based on that model, you look at the hardware that's required to kind of run that capability. So I will, if you have any comments here, I'll pause for that.
Well, yeah, I mean, the other interesting thing, and I was going to ask you about this, Hussein, is, one of the other amazing thing that's happened with AI models is we've seen the development of these frameworks, right? Part of the problem in the past was that to create a model from scratch was an extraordinarily difficult, advanced computer programming challenge. Now what's happened is a whole bunch of companies, and a lot of these are open source based projects, have created what they call a framework. Things like TensorFlow and PyTorch and some of these other things, Onyx and what have you, that are created that allow people to apply some of their, traditional computer programming skills to other kinds of problems. And then also the beauty of these frameworks is many of them are run independent of the underlying hardware or even the OS that they're on. So that's also, it seemingly has been a big change. I mean, have you seen that, being a big influence in terms of how, device designers and other people are trying to create these things, is the ability to use these frameworks?
Yeah, definitely training frameworks. There's plenty of them out there, and the choices are there for the designer to choose which way they want to go. Also, vendors are introducing tools in order to enable moving that trained model to their hardware specific to them. So using training framework requires you have a model. So first, the designer would need to go choose a model. And also the designer would need to go create a data set that is representative of where the final application is going to run. So for the robot example, if it's an indoor robot, you want to collect the data set that representative of that environment. And if it's an outdoor robot, you also do the same. So once you have that data set, normally designers will need to augment the data set to cover all corner conditions that they can think of at that point, and then go through the process of training that model. Once they have a trained model, vendors provide tools to grab that model from a framework like TensorFlow or PyTorch and bring it through their tools to modify it and make it fit into their quantization, pruning techniques are used in this instance. Normally, designers would run multiple model runs at the same time, and they decide based on very small testing criteria which model meets the requirements, and then take that and go into full validation of model, which is the third stage of the design that I talked about. So
just a quick question. Like it feels from talking to our customers, our partners in our ecosystem, that there's just a frantic level of innovation where you pick a model and you do development work, and then somebody across the street or in a different university somewhere has come up with a new model that does something X% better. It actually reminds me in like the 80s and 90s where video games were just getting, from 8-bit to 16-bit to 32-bit to 64, and the resolution was just going exponential in terms of how much better the games were looking. It feels like the same thing is happening with just some of these AI models and how they're generating output. Is it as frantic and as changing as it feels?
Yeah, so definitely there's innovations in models. We see models that are showing up in daily basis that continue innovation, and the designers of products, they need to think about how long that product is going to be on the shelf, and if they want to be able to upgrade it, and how much that change in model environments that are happening out there can be reflected in their future plan for the product. So that we definitely see model innovation increasing as we speak.
Could
Well,
you give
and
an
you know it's
example? I'm sorry, go ahead, Bob.
no, sorry, Matt. I was just saying, it's the wild, wild west because they call the places where they keep all these models zoos, right? Because it's crazy, it's like wild animals. But anyway, I mean, the reality is, like you said, I mean, these things are changing like crazy, really rapidly, and of course, that's a challenge for a lot of people, designers who typically have to make some difficult decisions up front around, hey, this is the hardware I can, leverage to try and create this device. And those are some of the challenges that in the past, frankly, have kept people from going very far with AI on these devices because, they lock themselves into a particular pattern or not, I don't mean pattern matching, but like a particular way of thinking, a particular design that in a way can limit the choices of what they're able to do. That's why there is this increasing need based on the speed of the changes in those models of more hardware flexibility to accommodate those changes. Because, again, over the weekend, something could, be available that's infinitely better than what you had been using in your initial designs. And that's the real world that a lot of these product designers have to face all the time.
Yeah, that makes a lot of sense. I think about just products all over my house that have added some level of smarts, but are immediately feeling, just very long in the tooth in terms of their capability versus stuff that's just launching a year later. So, Hussein, I would love to get, just to make it really relevant to our audience. How can we help in making the right decisions in both software and hardware in a way where you can plan on innovation while at the same time delivering these new types of AI experiences?
So at Lattice, we've been trying to innovate in the AI area for a while now, as FPGAs are always or available first, silicon is there. So we created a solution back around our FPGAs. We didn't want to just provide a silicon and let designers go figure it out themselves. So we provide the acceleration engines that are available to use in our devices, software tools like compilers, the one I discussed, to bring trained model into our environment. SenseAI Studio is another great tool that we have. SenseAI Studio provides an end-to-end training platform. It includes a model zoo. You can pick a model, you can pick a reference design that's doing, let's say, attention tracking, and start from that as a starting point and use transfer learning to build another application. So there is a number of tools that we put together. Another piece of it is being able to validate the model. We put some tools around model validation to make sure that the model would work and the application is intended to work and work for everybody. And that's an important piece for creating a final product that a consumer can use well.
So, Hussein, I am curious though, because you always hear that FPGAs, even though they're so flexible, because of course they can be reprogrammed essentially on the fly, but because of that flexibility, they're really hard to write applications and programs for. So, how do people who may not be that familiar with, leveraging FPGAs, but who want to be able to do AI on a device, how do they make that connection and that jump if they're not really an FPGA expert? Do you have tools to help with that as well, or?
Yeah, there are standard industry tools out there that make AI accessible for software designers, like TF Lite, and Lattice certainly has support for those type of tools. So you can create an SoC type of environment within a Lattice FPGA and create models that are software trained and bring those into our environment and program our device like it is an SoC. It has an MCU or CPU, and then it has all these accelerator engines in around it. This approach basically makes it that you don't need to have any RTL knowledge. You're really using industry standard tools to make the flow work.
Got it. Well, and the other interesting thing, and a point I was going to mention earlier is, a lot of the times we're thinking about some of the really kind of far out, really cool applications of AI and ML. But one of the things I've discovered and noticed is that sometimes it's the subtle things, it's the little things that can make a difference. Because ultimately, to me, that a device is effectively using AI ML when it just feels better and it works better. It's a little magical. Our smartphones are taking better pictures. We're not sure entirely what's going on, but we know that now when we take a picture, given a certain light situation, it can automatically adjust and it's doing things in the background based on AI and ML to do something different. In the case of a battery powered device like a PC, even things as simple as, hey, someone walked away from that screen, I can now shut off the battery and that'll preserve battery life. Or I can do recognition of the individual without requiring or knowing that, to confirm that somebody's actually there. Or I could block the screen if somebody walks by, and all kinds of little subtle changes that make the experience, they're not dramatically different, but they can make a difference. And I think part of both the challenge, the creative challenge and the opportunity for designers is how do they think of some of these kind of basic capabilities that enhance the overall value of a product and then combine them in a couple interesting ways so that all of a sudden you've got a device that just, like I said, feels smarter.
Yeah, I agree. AI applications should drive a useful application at the end to the user, drive longer battery life, for example, recognize the user when they want to use the machine. So make interactions with machines simpler is a great example of how AI can also be used. So I definitely agree with you.
There's a larger trend that we're really excited to be part of, and I personally find enjoyment in it. And I've got an electric vehicle, and every time there's a firmware upgrade, I get super excited because there's release notes that come out, and it's like, here's all the cool stuff your car can do now that it couldn't do yesterday, right? And that has a really cool feeling. Forget the business model of how you do that as your car company, or how you deploy that in different situations. But that feeling that a product could have a longer life cycle and can be upgraded to be smarter and add new features and capabilities is something that I think our customers see as an opportunity, and I know consumers are going to see as an opportunity. How should we think about that, Hussein, while we also think about what you said earlier, which is, hey, these models are changing really fast and trying to keep up with that? How does all of this upgradability really play out in the spirit of what you just described?
Yeah, you really have to pay attention to the programmability of the hardware that is being chosen to implement the solution. A software-defined application where you continuously update and change requires a lot of flexibility from a hardware perspective. And I think that's where FPGAs do the best job. FPGAs are programmable at their heart. So you can take, for an AI model, for example, take the acceleration engine and modify it to meet some new AI model that just showed up. And if you're using an ASIC, that means respinning the ASICs and coming back. But also, you get to take advantage of sensors that you weren't taking advantage of previously to add additional feature, as an example. So programmability, flexibility of the architecture, the interface to sensors, the interfaces to memories, that hardware selection it plays a big deal in how programmable and how much features you can introduce to the market in the product lifecycle.
Well, and the other interesting thing, we kind of hinted at this earlier, is the fact that you can now start to do some of this. It may be very basic, but you can still do some ML and AI on really small devices. I mean, things like tiny ML, right? Where you can theoretically do stuff in a very, very low power, within a very limited power range. And that opens up all kinds of possibilities because you've got a bunch of devices that never had the ability to do anything kind of reasonably intelligent, and that now theoretically all of a sudden can. And that's, I think, another interesting opportunity is, sure, we can talk about adding FPGAs to more powerful devices. And we haven't even talked about things like manufacturing lines where you can visually inspect parts coming off the line to confirm that they're okay and adjust accordingly. But even tiny devices theoretically can benefit from this. And I'm curious, Hussein, like what sort of applications and things are you seeing at that, small level?
Yeah, at the small power level, it's the conversational AI piece that plays the most. So you see devices that are able to listen to things in the microwatt range. That's really important because now you enable plenty of devices with battery to be more smart, to be capable to interact with humans easier. So I see conversational AI as that piece that can run at very low power.
Yeah, I mean, because that, one of the frustrations that we're all technical people and we're into the details, but you talk to the average person, and they get very frustrated with everything involved, whether it's a washing machine or a kitchen appliance or whatever, let alone dedicated tech devices. So the ability to bring that level of just, hey, do what I want you to do, not what buttons I push, like do what I meant. Essentially, it comes back down to sort of that simplistic level. But if you can enable that, that becomes really exciting and opens up a whole new level of opportunity to add digitization and intelligence and AI to a much wider degree of products than we've ever had before. And I think we're on the sort of the cusp of that starting to happen in the real world. At least it seems that's how I'm seeing it from my perspective, kind of looking out over the big picture.
Yeah, the way I see deep intelligence of devices is multimodal inferencing, ability to bring in multiple data from multiple sensors and understand the context under which the device is being used. And that includes the audio piece of it, being able to do some pattern recognition related to audio, but also, vision and other sensors that have more data can provide more context, but we definitely need to take care of privacy of the user. So no data needs to leave the device to go to the cloud. It all needs to be processed locally, and the device needs to be secure that it cannot be changed or hacked to extract some data or make it do something that it's not intended to do.
Yeah, I mean, that's a huge point, and I'm glad you brought up something I meant to bring up earlier. But the privacy and security implications of doing on device AI is enormous, because people were getting, initially people thought, oh, this Amazon Echo thing is pretty cool, right? I can ask it something, it responds. But then, of course, we heard the stories of people's voices being recorded and going up to the cloud, and a lot of people got really nervous about. They're like, hey, wait a minute, this isn't cool. But at the same time, they want the benefits of, well, we're trying to customize the experience for you. Well, I'd prefer if you could customize it within my own little world. So that the notion of on-device AI, I think, is incredibly important. And even now, right, it's a continuum. I mean, as people have at least explained to me, and I'd be curious to see your perspective. Like I said, when at the very beginning, early Echoes was basically 100% cloud, zero local. But you don't immediately go to 100% local, zero cloud. You kind of work your way down, 10% local, 90% cloud, 20/80, 30/70, and 40/60. And obviously we're still on that continuum, I think. And I'll be curious to see how that continues. But the ability to do certain really critical things locally, I think, changes the nature of the device. It changes the nature of the value, and it changes, in theory, the nature of the experience of using that particular device.
Yeah, I'll go back to example of the robot. Sometimes you can't get around actually doing it on device because you have latency requirements. So
Right.
that robot should not fall down the stairs or do something it's not expected to do. So definitely, there's a lot of advantages for doing things on device, and it preserve the privacy security of the user, and it just does it in a power envelope that's more helps saves the planet at the same time.
And there's a sense of the world is getting more used to more sensors, where you go back to before you had gyroscopes in phones, you had to hit the button to actually turn on the screen. Now you just expect the phone to turn on when you pick it up, off of a table. Now you've got cameras all over vehicles. You've got all kinds of radar sensors that are providing telemetry. So, it really is critical to make sure that the market understands, hey, what kind of information are these sensors generating to make things smarter? But at the same time, not creating any type of privacy issues, because not every image sensor is a camera, but it's getting information to then provide a smarter experience for some of these devices. So it's really cool to be part of this. And the best part for us is, hey, we work with every kind of sensor. We work with every kind of semiconductor SoC out there in the marketplace, and almost every possible different system application. We have over 9,000 customers. So what we look forward to as a Lattice team is actually getting to the use cases that our customers and our partners are trying to solve, and trying to figure out how to best employ the right hardware technology, the right software, and the right user experience capabilities to make those experiences really, really rich. So we're very fortunate and grateful and humbled to be part of this. It's awesome to talk to folks like you, Bob, that see this from every vantage point. We definitely want to do this conversation again. One thing before we wrap up, we have a lot of great content on the web for anybody in our community that would like to learn more, get reference designs, get tools on how to do many of the things we talked about. Hussein, could you just maybe wrap up by just letting people know where they could find more information on SenseAI and some of the things you talked about?
Yeah, the information I gave earlier, the hardware platforms, the IPs, the accelerator engines, the software tools, reference designs, demos, all of these are available at latticesemi.com/SenseAI. It's a great source to get going. You can download SenseAI Studio and pick up a design and try to do something with it. It should be a quick 30 to an hour exercise, 30 minutes to an hour.
Awesome. Hey, Hussein, thanks a lot for that detail and being part of the panel. Bob, thank you again. We appreciate you and everybody at TECHnalysis Research for all the hard work you guys do to really to just help the market understand where things are going and how we can better help our ecosystem. So really want to thank you for your partnership on being in the panel today.
Thanks for having me. I appreciate it, Matt.
And to all of our subscribers and to all of our viewers, thank you very much for joining. We're going to continue to have these sessions as we see cool, innovative topics in the marketplace where we're helping, and we need your help to make that ecosystem even smarter and help us innovate. So thank you to all the viewers today. Have a great day.
Thank you.
Thanks.